Okay, so in part two, we're going to talk about determining information from a graph. So you can be given a graph, and there was some stuff that you have to find based on the graph. And then the other thing we're going to do is to evaluate. And that's an E right here. So we can evaluate functions. Okay, so let's look at the first part. So given a graph, you're going to determine information. So let's look at this one. All right, so number one, you have this. Um, so you're given this, and remember from last semester, that's a parabola, and this is a line. And so I'm going to have to do this closer like this, but for number one, you want to find f of negative 2. Now what that means is this. That means that you want to find the y value when x is negative 2. That's what you're asked to do. So you want to find y when x is negative 2. So find y when x equals negative 2. So you go to your graph and you look at this. Well, x is negative 2 here. So that's where x is negative 2. So you go to the graph and you point and you figure out where that point is. This is the point when x is negative 2 right here. And so the question is, when x is negative 2, what's the y value? Well, the y value is 4. So the answer here is going to be 4. Okay? So again, this means, remember f of x means y. So remember that f of x means y. So you want to find f of negative 2, so we're going to find the y value when x is negative 2. So you look for where x is negative 2, x is negative 2 here, look at the point, what's that y value? Well, the y value is 4. Same thing here, so again you want to find the y value when x is negative 4. Well, here's where x is negative 4, here's the point, so the point is here, so that's the point where x is negative 4. And so the question is, what's this y value? Well, if you plot that point, negative 4, my y value is 0. That's the point here. So your y value is 0. Okay? So the next one is you want to state the x-intercepts as an ordered pair. Remember the x-intercepts and x-intercept is where the graph crosses the x-axis. So if you look at this graph crosses the x-axis here and here. So there are two places where the graph crosses the x-axis. And all they want you to do is list this as an ordered pair. So here, and I already listed it, so that ordered pair is negative 4, 0. And the other one here, that's the origin, so the origin is going to be 0, 0. So the other ordered pair is 0, 0. So negative 4, 0, and 0, 0. Then they want you to state the y-intercept as an ordered pair. Well, if you look at this, remember the y-intercept is where the graph crosses the y-axis. So the graph crosses the y-axis. Well, here's your y-axis. The graph crosses the y-axis here, which is the same place where the origin is, where this graph crosses the x-axis. So remember, the graph crosses the x-axis twice, here and here. That also happens to be the y-intercept. So this point here happens to be the x and the y-intercept. So that's going to be 0, 0. Okay, so now they want to know this. They want to know for what values of x is f of x equal to 3. So in other words, find x when y equals 3. Remember f of x means y. So find x when f of x is y equals 3. So you got to go to your graph here. See, y is 3 here. That's y equals 3 right here. And so you look at the points that correspond to it. So the points that correspond to it are here and here. All right, so again, y equals 3 is here. The points that correspond to it are here and here. And if I label these points, I will determine my answer. So that point here is, let's see, that's going to be negative 3, 3. And that point here, this right here, is going to be negative 1, 3. Negative 1, 3. All right, so let's go back to the question. The question is this. For what values of x is my y value equal to 3? Well, my y value is 3 here. My y value is 3 here. The values of x that make y equal 3 are negative 1 and negative 3. So you would say, here's how you would answer that. You would say x equal negative 1, comma, x equal 3. I'm sorry, negative 3. All right, because when x is negative 3, look at this. When x is negative 3, What's your y value? Your y value is 3. When x is negative 1, here's the point. What's your y value? Your y value is 3. Okay, then next one is for what values of x is f of x equals 0. So again, the same thing. F of x means y. So find x when y equals 0. Well, y is 0 on the x-axis. No matter where you are on the x-axis, y is going to be 0. So you see, I already have, based on some of the other questions, I already have the answer. Remember, I want to know where's y 0? Well, y is 0 when x is what? Well, y is 0 here, and y is 0 here. So y is 0 when x is 0 and when x is negative 4. So y is 0 when x equals 0 and x equals negative 4. And then here, for what values of x is f of x equal to 4? So again, same thing. Find x when y equal 4. Find x when y equal 4. Well, when y equal 4, that's right here. I already determined that from a previous problem. So when y is 4, what's that x value? Well, the x value is 2. When y is 4, the x value is 2. So the answer is going to be x equal 2. Because when x is 2, negative 2, excuse me. That should be negative 2 right here, I'm sorry. Negative 2. So when x is negative 2, I get the y value to be 4. Okay? All right, so go back over this. All right, so let's look at this one. So here you want to find f of 2. So you want to find, again, find y. So find y when x, remember f of x, so x, 2 takes the place of x. So when x is 2, what's that y value? Well, when x is 2, here's when x is 2. I go to the graph and I look at the point. So that's going to be this point here, right here. So when x is 2, the question is, what's that y value? Well, the y value is 8. So the answer here is 8. Okay, next one. When x is negative 4, what's the y value? Well, I go to the graph. Here's x equal negative 4. The point of the graph is going to be this right here. That right here. So when x is negative 4, what's that y value? Well, the y value is negative 4. So the answer here is negative 4. All right, then you want to state the x-intercepts as an ordered pair. So the x-intercept remembers where the graph crosses the x-axis. So where does the graph cross the x-axis? Well, the graph crosses the x-axis here. So then you want to determine what that point is. Well, that point is negative 2, 0. Negative 2, 0. All right, next one. Find the y-intercept as an ordered pair. So where does the graph cross the y-axis? Here's the y-axis. The graph crosses the y-axis at this point here. So this is the y-intercept right here. As a point, as an ordered pair, it is 0, 4 as an ordered pair. Not 4, 0. 4, 0 is here. This is 0, 4. So that goes here. Then you want to find what's the y value of x if y equals negative 8. Well, if y equals negative 8, that's this right here. That's where y equals negative 8. Look at the point that corresponds to it. The point that corresponds to it is right here. Right here. And the question is, when y is negative 8, what is that x coordinate? Well, the x coordinate is going to be negative 6. So when y is negative 8, the x coordinate is negative 6. So find the value of x when y, f of x, y equals negative 8. You would say x equal negative 6. Okay? All right, number 3. Okay, number 3 is going to look like this. All right, so this is number 3. All right, so you want to find f of 2. That's f of 2. So you want to find what's the y value when x is 2. When x is 2, that's here. The point of the graph is right here. So when x is 2, that's the point 2, negative 1. 2, negative 1. So f of 2 equals a negative 1. You put negative 1 there. F of negative 3. So this is your function f. Let's say this is f of x. That's what these f's mean, the function. So when when x is negative 3, here's where x is negative 3 right here. Look at the point. That's the point. So when x is negative 3, what's that y value? Well, the y value is negative 4. So f of negative 3 is going to be your y value, which is negative 4. That's what goes here. F of 0, remember f of 0 means what's the y value when x equals 0? Here's where x is 0. Look at the point. That's that point right here. And so that point represents 0, negative 3. So when x is 0, the question is what's that y value? Well, the y value is negative 3. Okay, state the x-intercept as an ordered pair. Well, where does the graph cross the x-axis is what you're asking. The graph crosses the x-axis here. That ordered pair is going to be 3, 0. So the answer is 3, 0. Find f of 20. Well, if f of 20 is going to be way out here. See, that's 6, 7, 8, 9, 10. That's way out there. And you might say, well, it only stops at 6. No, it doesn't. Remember, this is an arrow keeps on going. Look at this arrow. So that's more of a horizontal ray. See that horizontal ray? So what do you notice about all these y values on that horizontal ray? Well, if it's horizontal, that means that they are all the same value. So the question is, what's this y value? Well, the y value is 1. So all of these numbers here are going to be 1. So f of 20 means when x is 20, what's that y value? Well, that y value is going to be 1. So the answer is 1. F of negative 100, the same idea. F of negative 100. So f of 3 is negative 4. F of 8 is going to be negative 4. F of 1,000, negative 1,000 is negative 4, and so on. See, all these y values are negative 4. So f of negative 100, so when I go to negative 100, that point that's on the graph is going to have the y value being negative 4. So the answer is negative 4. Okay, state the y-intercept as an ordered pair. There's only one y-intercept. That's this one. We already found it. So 0, negative 3. Okay, the next one. For what values of x is my y value negative 2? Remember, you're asking find y when x equals negative 2. I'm sorry, find x when y equals negative 2, because f of x is y. So find x when y equals negative 2. So y is negative 2 here. See that on the y-axis, negative 2? So look at this point. That's the point that corresponds to it. Here's y equals negative 2. The point that corresponds to it is right here. So if you look at the ordered pair, that's the ordered pair 1, negative 2. So now we can answer the question. When y is negative 2, see negative 2, question is what's this x coordinate? Well, the x value is 1. So the answer is 1. X equal 1. Same thing here. So find x when y equals negative 1, because f of x is the same thing as y. So when y is negative 1, that's this right here. So this right here, look at the point that corresponds to it. That's this. So when y is negative 1, we already found it. What's the x coordinate? Well, the x coordinate is 2. So we'll say x equal 2. Okay? All right. So you may, some of you may get this right away, but just go back and look at this video. It's not that difficult. It's just being able to read and notice as we go through this, we did some stuff, and some of the later stuff, we could just go back to what we did. Okay, so there's some similarity between some of the questions here. All right, now let's look at this one. Okay, so what we did was from a graph, we determined some information. That's what we did. Now let's go ahead and evaluate function. Okay, so let's look at this function here. So let's suppose I have number 1, so you could evaluate each function. Okay, number 1. Let's suppose this was my function. F of x equal a negative 2x squared plus 3x minus 1. All right, and you want to find f of 2. Well, remember last semester when you do this, so where we saw some of this is going to be a review, some will not, some will. Where we saw the variable x, you plug in 2. So you said 2 into here, 2 into here. All right, and so you said, well, that's going to equal negative 2 times x. Well, x is 2, but I'm squaring that, plus 3 times 2, 3 times x is 2, minus 1. And then I just use the order of operations. So the order of operations, I'm going to use the exponent before multiply, do the exponent before multiply. 2 squared means 2 times 2, so that's 4. That's 4. 4 times negative 2 is negative 8. Plus 3 times 2 is 6, minus 1. Negative 8 plus 6 is a negative 2. A negative 2 and this negative 1 is a negative 3. So f of 2 equals negative 3. You'd put that in the blank. Okay, so you put that in the blank, negative 3. So that means that on the, remember as an ordered pair, let me just say this, as an ordered pair, remember x is 2, and then f of 2, that's your y value. My y value is negative 3. So that's what we found. So this ordered pair would be on this graph. Okay, so this was part A. Part B, let's suppose you want to find f of negative 3. F of negative 3. Well, to find f of negative 3, I go back to my function. Wherever we see the variable x, I'll plug in negative 3. So I'm going to say f of negative 3 is going to equal negative 2 times x. X is negative 3. I'm going to square it. I'm going to say plus 3 times x. X is negative 3 minus 1. So negative 3 squared means negative 3 times itself, which is 9. 9 times negative 2 is a negative 18. 3 times a negative 3 is a negative 9, and then minus 1. So negative 18 and a negative 9 is a negative 27, and a negative 27 and another negative 1 is a negative 28. All right, so f of negative 3 is going to equal a negative 28. So if you were to graph this as an ordered pair, now that's what you put in the blank. You put in the blank negative 28. As an ordered pair, this would be your point. Remember x, y. So this is your y value, this is your x. So x is negative 3. So my y value is negative 28. All right. C, suppose you want to find f of negative x. Okay, so let's think about this now. So this is no longer a number. Here we're substituting numbers, 2 and negative 3, and now we're just substituting a variable expression. So again, just do it like you did a while ago. All these, when you plugged in negative 3, when you plugged in 2, same idea. So you can say f of negative x is going to equal negative 2. So basically, where we see the variable x, you're going to plug in negative x. So remember, f of x is this. So f of x equals negative 2x squared plus 3x minus 1. So wherever you see the variable x, you're going to plug in negative x. Okay, so that's what you're doing. So I'm going to get negative 2 times, in parentheses, negative x's. That's what I'm substituting, but I'm going to square it. Plus 3 times x, but I'm substituting a negative x there, so substitute the negative x, and then minus 1. Okay, using the order of operations, negative x times a negative x, remember negative x times a negative x is a positive x squared. So this part here is x squared, and x squared times a negative 2 is a negative 2x squared. 3 times a negative x is a minus 3x, and then minus 1. So notice that when you plugged in a number, you ended up with an answer being a number. So when I plugged in 2, when I substituted 2 into my expression, I got negative 3. So when x is 2, my y value is negative 3. When I plugged in negative 3 into the expression, I ended up with a number, negative 28. So when x is negative 28, my y value is, when x is negative 3, my y value is negative 28. Here, though, when I plug in a variable expression, I end up with a variable expression. I did not get a number because this is not a real number. It's a variable expression. So I get this. Okay? All right, so let's look at another. All right, number 2, let's suppose this was my function this time. So let's suppose in number 2, I had f of x equals the square root of 2x minus 1 plus 6. Oops, sorry. 2x minus 1 plus 6 and plus 6 on the outside. All right, so let's see what we got. So let's find part A. Let's find f of 4. F of 4. All All right, so f of 4, where we see the variable x, I only see it once, I see it here. You're going to plug in 4. So I get f of 4 would be the square root of 2 times x is 4, minus 1, and whatever that is, I'm going to add 6. And so I'm going to get 8, 2 times 4 is 8, so 8 minus 1 plus 6. So the square root is 7 plus 6, and that's about all you can do. Just leave it like that. All right, so that's your answer. So the square root is 7 plus 6. So you say f of 4 will equal the square root of 7 plus 6. Don't say the square root of 13 because that's not a square root here. So don't say square root of 13. Okay, now if it was this, I'm not even going to go there. All right, so don't say square root of 13. Those are not like terms. And even if it was square root of 6, you still couldn't combine them because that's the square root of 7, that's the square root of 6, and the radicands are different. So you couldn't combine them either. So don't make that mistake. The only way that would have been a 13 is if this whole thing, see if it was this, then it'll be the square root of 13. All right, but that's not the square root of 6. I'm sorry. So the 6 is not under the square root with the 7. Okay. All right, let's look at this one. So B. Suppose you had f of, let's say 1/2. F of 1/2. All right, so where we see the variable x, you plug in 1/2. So I get the square root of 2 times 1/2 minus 1 plus 6. 2 times 1/2 is 1. 1 minus 1 plus 6. 1 minus 1 is 0. Square root of 0 plus 6. Square root of 0 is 0. 0 plus 6 equals 6. So f of 1/2 equals 6. C, suppose you had f of, let's say, 3x minus 1. F of 3x minus 1. Now I'm going to go back and rewrite this. So remember, f of x is this. So that would be the answer for that one, by the way. F of 1/2 equals 6. So f of x, remember, is the square root of 2x minus 1 plus 6. So where we see the variable x, I'm going to plug in. Now you got to think about this. I'm going to plug in this thing right here because that takes the place of x. I'm going to plug that into here where we see the variable x. I only see it once here. So here's what you get. You get the square root of 2 times x, but I'm substituting this in place of x. Whatever that is, I'm going to subtract 1, and then I'm going to add 6 to this whole thing, like this. Okay, simplifying the radicand, I'm going to distribute. So it'll be the square root of 2 times 3x is 6x. 2 times a negative 2 is a negative 2. And then minus 1 plus 6. So that becomes the square root of 6x. A negative 2 and a negative 1 is a negative 3 plus 6. And again, that's all you can do. You can't put these two together. All right, so that's all you can do. So there's your answer. So you'd say f of 3x minus 1 equals the square root of 6x minus 3 plus 6. So that's the answer there. All right, number 3. All right, suppose you had all right, so number 3, suppose you had g of x. So remember, your function notations like f of x, g of x, h of x, they all stand for y. Remember, same idea for y. If you're plotting these things in a coordinate plane, the g of x will be your y value. So let's say g of x was this, was the absolute value of 3x minus 1 divided by x plus 2. Right, let's suppose we had that. All right, so let's find g of 3. Find g of 3. Well, g of 3 then would equal, so wherever I see the variable x, I plug in 3. Now remember, since I'm plugging in a number, I'm going to get a number for my answer. So when I plug in 3, I get the absolute value of 3 times x, x is 3, minus 1. Notice the absolute value bar is still there. Divided by x, x is 3, so it's 3 plus 2. Equal. 3 times 3 is 9, so I get the absolute value of 9 minus 1 all over 3 plus 2 is 5. 9 minus 1 is 8. The absolute value of 8 over 5, and the absolute value of 8 is 8, so I get 8 fifths. So make sure you write the answer without the absolute value bars. So 9 minus 1 is 8, and the absolute value of 8 is still 8. Okay? B, suppose you want to find g of negative 4. G of negative 4. Well, again, where we see the variable x, you plug in, and see it twice, you plug in negative 4. So I'm going to get equal the absolute value of 3 times a negative 4, because that's your x, 3x, so that's a negative 4, minus 1, all over x, which is going to be negative 4, and then I'm going to add 2. X plus 2. X is negative 4 plus 2. All right, simplifying the numerator, 3 times a negative 4 is a negative 12. Negative 12 minus 1 divided by negative 4 plus 2 is a negative 2. Negative 12 and a negative 1 is a negative 13 divided by negative 2. The absolute value of a negative 13 is a positive 13 divided by negative 2. So you can say that's your answer, or you can say negative 13 halves. So you'll say g of negative 4 is negative 13 halves. Okay, C, suppose you want to find g of x plus 3. G of x plus 3. Now remember, see how I plugged in a number and I got a number? Well, remember, when you plug in an algebraic expression, you're going to end up with an algebraic expression. So let me go ahead and just rewrite the function here. So g of x, remember, was this. Has the value of 3x minus 1 divided by x plus 2. So wherever you see the variable x, you're going to plug in what g of x is. So you can plug in what's inside the parentheses, because this was x. G of x, x is now x plus 3. So you can plug in wherever you see the variable x, you can plug in x plus 3. So I'm going to get the absolute value of 3 times, don't forget the parentheses though, because all of this has to be multiplied by 3. So it's 3x. So 3 times x plus 3, so 3x, and remember x is x plus 3, minus 1, absolute value, divided by x becomes x plus 3 plus 2. So x plus 2, x, remember this is x, which is now x plus 3 plus 2. Okay, well, distributing this, I get the absolute value of 3x, and then 3 times 3 is 9, so 3x plus 9 minus 1 over, and then combine like terms here, that's x plus 5. Combining like terms here, a positive 9 and a negative 1 is 8, so the answer is 3x plus 8 divided by x plus 5. So notice, I want to find g of x plus 3. So since I'm plugging in an algebraic expression, my answer is going to be an algebraic expression. So the absolute value of 3x plus 8 divided by x plus 5. Now notice the difference between this and the other one. Okay, so look at the other one. So see how at this point I took the absolute value of 8 and I said that was exactly 8? That's what you need to do, because that was a number. You know the absolute value of 8 is 8. Here, you know the absolute value of negative 13 is 13. Here, though, the reason you can't just remove the absolute value bar is because you're not plugging in anything for x. So x could be a number in which this would be negative, and x could be a number in which this could be positive. So since I still have a variable expression, you must leave the absolute value bars. You don't take them away. They must still be there. So the answer is not, don't say, g of x plus 3 is 3x plus 8 over x plus 5. That's incorrect. Don't forget the absolute value bar. You must have the absolute value bar. Absolute value bars. Okay, you must have. All right. Okay. So let's look at another one. So let's look at number 4. Suppose we had h of x is equal to 6x minus 1. All right, so h of x equals 6x minus 1. And let's suppose that you want to find h of negative 2. So wherever you see the variable x, I'm going to plug in negative 2. Now, see how I'm substituting negative 2? I'm going to end up with a number. So wherever you see the, wherever you see the variable x, you plug in negative 2. So I got 6 times negative 2 minus 1. 6 times negative 2 is a negative 12. And the negative 12 minus 1 is a negative 13. So h of negative 2 equals blank. You'd say negative 13. B, suppose you want to find h of negative x. So again, wherever you see the variable x, you plug in negative x. So I'm going to get 6 times x, x becomes negative x. That's what you substitute. So you substitute this in place of your variable. So wherever you see your variable, you plug in this thing that's in parentheses. And then minus 1. 6 times a negative x is a negative 6x, and then minus 1, and that's all you can do. There's your answer. So you say h of negative x equal negative 6x minus 1. C, suppose you want to find h of 2x minus 3. So again, wherever you see the variable x, this is what you plug in. You substitute this. So underlying this sometimes helps. So you're going to substitute that into here. So I'm going to get 6 times x. X is 2x minus 3. Don't forget to put that in parentheses because all of this is going to be multiplied by 6. And then you could don't forget to subtract 1. So again, notice this is 6x, which you're substituting this, minus 1. And so distributing, I get 12x minus 6 times 3 is 18, minus 1. So that's 12x. A negative 18 and a negative 1 is a negative 19. So there's your answer there. So you'll say h of 2x minus 3 equals 12x minus 19. So that's what you'll put in the blank. Number 5, suppose you had this. Number 5. Suppose you had, let's see, all right, suppose you had f of x equal 4x squared minus 1 over x squared. So 4x squared minus 1 over x squared. And let's say you want to find a, and let's say you want to find f of 2. F of 2. So wherever you see the variable x, you plug in 2. So I get 4 times x. X becomes 2. That's what you plug in. Wherever you see the x, you plug in 2. So 2, but don't forget for this one, you're squaring it. Minus 1 all over, and then just x squared. So that's 2 squared. So x squared, 2 squared. So 2 squared is 4. 4 times 4 is 16. So I get 16 minus 1. And then this is 2 squared, which is 4. 16 minus 1 is 15. So you get 15 fourths. So f of 2 equals 15 fourths. All right. B, suppose you want to find f of negative 2. Same thing. So wherever we see the variable x, you can plug in negative 2. So underline it to remind you that in place of x, this is what you plug in. And notice whenever you plug in a number, you get a number. If this was a variable expression, you get a variable expression. So f of negative 2, I'm going to get 4 times negative 2 because that's your x. But I'm squaring it. See where it says 4x squared? 4 times x. X is negative 2, and then a squared. And then don't forget, I got to subtract 1. All over, and then x squared. So that's negative 2 squared. Okay, negative 2 squared, remember, is 4. 4 times 4 is 16. So that's 16 minus 1 over negative 2 squared. It means negative 2 times negative 2, so that's 4. And so I get 15 fourths also. So f of negative 2 is 15 fourths. So notice that the 2 and negative 2 are opposites, but their y values are the same. That's going to mean something later on in terms of even functions. So you're going to learn about even functions soon. So there's something called even functions and odd functions. Okay, C, suppose you want to find f of negative x. And so again, wherever you see the variable x, this is what you're going to plug in. You're going to substitute this expression into the variable x. Now, let me go ahead and rewrite it here. So remember, f of x was this. 4x squared minus 1 over x squared. So where we see the x, remember you want to plug in negative x into this. So where we see the x, you're gonna substitute. You're gonna substitute negative x. So I'm gonna get equal. So f of negative x is gonna equal, and you're gonna say 4 times negative x squared, because in place of x you plug in negative x, minus 1 divided by negative x squared, because x is negative x. That's what you substitute. Well, negative x squared, remember, means negative x times a negative x. That's what it means, negative x times a negative x. Well, a negative times a negative is a positive. X times x is x squared. That's all it is. So this is 4x squared. So 4x squared minus 1 over, and again, negative x times a negative x is x squared. And there's your answer. So f of negative x would equal this. That's what you would put in the blank. You put this in the blank. All right. Okay, so that's going to take care of part 2. So part 2 of this lesson, we can find the original page. All right, so what we did here was given a graph. So that's this part here. So given a graph, you found some information from it. Then what you did next was you evaluated functions. So given a function, evaluated that function at different values. Some of the what you substituted, some cases were numbers, in which case you ended up with a number as your y value. And in some cases you substituted variable expressions, in which you ended up with a variable expression. Okay, so just go back over these and make sure you review this part. So that takes care of part 2.